Okay, so we are talking now about page 44, and we're going to do the calculator work that we need to do for page 44. Again, I'm going to have another video where I go through all these notes and you just kind of have to splice them together. So at certain points I'm going to say stop this video and go watch that calculator video and then come back. So we're looking at example number 1 on page 44, okay? And we have this example here. You can see the table there. Audrey's interested in how speed plays a role in car accidents. She knows there's a relationship between the speed of the car and the distance it needs to stop. She's found the following experimental data, and she wants to write up a summary for the grad class. So we're going to use our technology. Dun, dun, dun. And we're going to figure out which of the three is going to be the best correlation. Okay, and then we're going to just answer the questions. Alrighty. So turn on my calculator, clear it. First things first, we're going to make sure our diagnostic's on because that's important, right? So second function, 0 minus x to the negative 1. Scroll down, turn diagnostic on, it's done, it's on, okay? If you ever do this and then you don't get the r² value, it's because you forgot to turn the diagnostic on, okay? And some calculators you might not have to turn it on, so it depends, but for these ones you want to make sure it's on, okay? Then we're going to clear all our equations. There's nothing in my y. Let's check. Oh, we know there's stuff in here from the last one, so we're going to clear, and we go up to the top, and we're going to clear. So we've cleared our lists. We're familiar with that. Then we're going to insert the data from the chart. So we're just going to type this in. 90. I want to make sure we can see everything. Look kind of dark. 36, 65, 56, 65, 24, 35, 55. And then go over to column 2 and enter in our y values. 94.4, 17, 49.2, 50.3, 43.1, 10.9, 14.2, and 57.3. Take a look over your data, make sure that it's all correct, because sometimes we put the wrong things in and we don't want that to happen, right? Looks all good to me. So we've got our data. Okay, now we're going to check and make sure that our stat plot is on. So second function, y equals stat plot. It is on, so I don't have to worry about it. It's turned on. So I can enter it and just double check, but it is. Clear that. Now I want to graph it. So what I do is I hit zoom 9 and it figures out my scatter plot. So at this point, you can sketch that scatter plot in the little box that is on page 44, okay? Now I want to check my R values. So I've got another piece of paper to record them as I go through. So we're going to go stat, we're going to go calc, and we're going to check our linear regression. I put in second function 1, comma, second function 2, and enter. So for linear regression, I get my r² value is 0.9004. We're just going to do 4 decimal places at this point. Okay? That's interesting. I got a different one before. That makes much more sense. Okay, I must have done something wrong when I did it last night. Never mind. Now we're going to clear that and we're going to do our quadratic. So that's 5, and I go second function 1, comma, second function 2, so that I'm looking at the x's and y's, and then enter. So our quadratic, our R2, is equal to 0.9075, okay, we'll include that. I think it actually rounds up to 6. Okay, so it is slightly more correlated than the linear regression. If I compare my two numbers, my linear regression is less. It's further away from 1. So we're not done. Clear that. We're going to go stat, calc, and we're going to now do our cubic regression. So we're going to press number 6. And again, second function 1, comma, second function 2. Enter. It's thinking. For our cubic, our r squared is 0.9106 ... So comparing those three numbers, which one is closer to 1? Well, it's the cubic. So cubic is our answer there for that expression. Okay, so cubic is, based on that, cubic is the better choice. So in that respect, it means we're going to change question B, because B says determine the cubic regression equation rounded to the nearest 10,000th. So looking at these numbers, that means that it's basically given me all my values there. Y is equal to ax cubed plus bx squared plus cx plus d. I know my a is 2.2662, rounding to the 4th decimal place. I should actually round that up to 3 because it's followed by a 5. B is negative 0.034, and I should round up that 2 to a 3. Okay. C is 2.765, and that 3 rounds up to a 4. And D is equal to negative 43.4456. So I can substitute all those in, and I can write my equation. So those are my values, and all I have to do is write those in for A, B, C, and D. I leave my x's in there because I want the whole equation. Okay? Once I do that, I can type that in to my calculator. Yes, I know there's a way I'm supposed to be able to just save it right in, but it's not working for me. If you find a way that makes it work, you let me know, okay? So we're going to put that in. 2.2663 x to the 3 plus negative 0.0343 x to the 2 plus our C was 2.7654 x plus a negative 43.4456. So now my equation is in there, and let's see what this looks like when we graph it along with the scatter plot. What? Where is it? Did I make a mistake? Let's double check my numbers. Maybe it was still thinking. Well, that's not good. It should graph a line right along with it. I wonder. It's all there. I'm just going to do something here. You're loving this because it's a video and you're saying, Mrs. Finley, shouldn't you figure this out? And I did last night. So, oh, you know what I did? Let's look back. Hey, graph this, go clear. It's 10. Look what I did. Look at that A. It's times 10 to the negative 4. That's what that E negative 4 means. So this is not that. It's actually 0.0022. Oh, actually there's 3 zeros. 0.02266. Aha, my mistake. Be very careful. Don't be like Mrs. Finley. Read the screen. This E negative 4 means times 10 to the negative 4. So it's a very small number. So that's going to change here. This is going to be negative. Oh, not negative, sorry. It's going to be 0.0002. We'll just put 23. Because of rounding. We probably don't even need it that much. It's going to make a difference. Watch. Now, you may say, oh, miss, that looks kind of like a straight line, but it's not. There is a curve there. It is just the curve of that line, and it just has to do with the window that we're using. So there is a curve there. Learning experience there. We'll treat that whole exponent thing as a teachable moment. Okay? So from that, we can then answer questions. So it says, use your equation to compare the stopping distance at 30 kilometers per hour with the stopping distance at 50 kilometers per hour to the nearest tenth of a meter. So looking at our graph, our y value is 30 kilometers per hour. So our speed is 30 kilometers per hour. That's our x value, right? So our speed is our x value. So we're going to put in 30 for x. So second function trace value, and we'll just put in 30. And that tells us that y is, you can see it there, 14.85. So 14.8 or 14.9. Okay. And then we can find out the other one. So second function trace value, and we'll put in the 50. And we get y is equal to 37.82 kilometers or meters, because we're looking at stopping distance. Okay. Now, I have a extra digit because I only had to do it to 4 decimal places. So this would be slightly different if I delete that 3 and graph it. It looks very similar, but if I put these values in, just changing 1 decimal is going to have an impact, because look what happens. If I go second trace value and I do 30, I get 14.0. Okay, so it can change it that much if you take out 1 digit. Okay, and you're saying, now, Mrs. Finley, how are you going to do that? Because you took that digit out, and I'm going to go, oh, I know. But we're getting approximate, right? That's what I should have done originally anyways. Okay, so let's look at the next one. D, determine the maximum speed the car should be traveling in order to stop. So here, within 4 meters, the average length of a car. So we want it to stop within 4 meters. Let's check our windows out and make sure that works. Well, my y minimum is -3, so that should work. Okay, so if I go into y equals and I put a 4 there, what it's going to do is it's going to draw a line across 4. So it's pretty low. So let's actually change our window so we can see it. Let's change this to -10. And then we'll graph, and we can probably see our line a lot better. So we're drawing our curve, and then it's there, but that's okay. Our function will still work. So we've got 2 lines there, and we're going to go second function trace, and then we're going to choose intersect, because we want to find the intersection point between the curved line and the straight line. So 5, and all we have to do, it says first curve, yes. Second curve, yes, I'm on the second curve. Guess, you betcha. And it tells me that it intersects at x is 22.7 and y equals 4. So that means that at 22.7 kilometers per hour, we've got a 4 meter stopping distance. Okay? So that's page 44. Again, I'm doing these in chunks to kind of break it up to see what you need to know. All right.